Hello, welcome to Science 1 or Physics. So we have a question here on parallel circuit, electricity, parallel circuit. So parallel circuit, things that you have to understand on parallel circuit is see that voltage is the same. Meaning voltage here is the same. Of course, resistance is different, and current is the same. But what is the same in parallel is what? Voltage is the same. So if they ask you to find voltage here, is 10. The same voltage which is here, the same supplied energy here, it's the same which is here. Again, the same supplied energy which is here, it's the same here. That's the most important thing that you have to know. Apart from voltage being the same, also you have to know how to calculate the total resistance, which can also be termed as the effective resistance. So here the question is saying below shows a circuit with two resistors in parallel connected to a 10 volts battery. So we have a battery here, then 10 volts, then resistance 3, and resistance here 6. And the question now is saying what is the effective resistance offered in the circuit. So we have two ways on how you can calculate. Of course, I'll start with the one which is simple. So if they say calculate effective resistance in parallel, so meaning you want to calculate total here. Total here, you're not supposed to add 3 plus 6. No. So in parallel, what you do, unless when you're in series, look out for another video which is the which has the circuit in what series. But this one, it's in parallel. You're not supposed to add. Instead, you use this formula. You say effective resistance is equals to product of resistor 1, resistor 2 over resistor 1 plus resistor 2. So that's the formula for effective resistance for two resistors. 2. For 3, you can inbox me. I will show you for 3 what? Resistors. Okay, R1, you can say this is your R1 or this is your R1. Doesn't matter. But if this is your R1, automatically this becomes your what? R2. So R1, 3 times R2, 6 over R1, 3 plus R2, 6. You multiply, calculators are allowed. 3 times 6, you have what? 18 over 3 plus 6, 9. 9 into 18, 2. The units for resistance, ohm. Done. 2 marks. Okay, next now it's okay, let me also show you another method. In case you're not familiar with this format here. You can also say 1 over effective resistance. It's the same thing, but now with different what? Formula. So you say 1 over effective resistance is equals to 1 over resistor 1 plus 1 over resistor 2. So you say 1 over effective resistance equals 1 over resistor 1, 3 plus 1 over resistor 2, 6. Lowest common denominator here, 6. 3 into 6, 2 times 1, 2. 6 into 6, 1 times 1, 1. Then now you add here. 2 plus what? 1, 3 over 6. You have equals between cross. 3 times the effective resistance, 3 effective resistance equals 6 times 1, 6. What we need is this. So you say over 3, over 3. This and this will go. So 3 into 6, 2, which is the same. It's the same. Okay, so let us jump to question B. So B here is saying calculate the current flowing from the battery. Now we need current. Then now they are mentioning battery. then battery, meaning you use the whole voltage for you to calculate what current. Again, you use the whole resistance in the same battery. So in short, you use the formula for Ohm's law, which is this, where there is R here, because we are calculating current, which is in the battery, meaning is the total current in short. So where there is R here, you put the whole what resistance, total resistance, or effective resistance, 2. V, the whole voltage, 10, over current, the whole current now. So here now you say over 1 cross, 2 times I, 2I. 1 times 10, 10. What we need is what? I. Over 2, over 2. I is equals to 2 into 10, 5. So this is your total what? Current. 2 marks. Done. Next, now determine the charge. Now we need charge. Check. We need charge which is flowing in the battery. And in the same battery, we have total current, we have total resistance, and what else? You have been given also what? Time. So meaning the one which has the combination of all those is this one. Current is equals to rate flow of charge with time. So that's the formula you use. I here current, then this here charge, then this here time. So now what we need is what? What we need is what? Charge here. So meaning current, you have current, 5. Charge, that's what we need. Over time, 1 what? Minute. Now here, you won't use the minutes, but you use what? Seconds. And everyone knows that in 1 minute, we have how many seconds? 60 seconds. So meaning where is T here, you put what? 60. Over 1 cross, charge times 1, charge. 5 times 60, 5 times 0, 0. 5 times 6, 30. Then the units for charge, column. Done. So that's how you're supposed to answer a question like this. For what? Parallel. Just know how to calculate total current and also how to calculate what? Effective resistance, same as total what? Resistance. Let's end here in parallel.